Hello YouTube. Today I'm going to talk about rainbows. In particular I want to address some comments made by Bas van Fraassen in his article Constructive Empiricism Now. Bas van Fraassen is a constructive empiricist. For those of you who haven't seen my series on scientific realism, let me explain this briefly. Basically, according to constructive empiricism, the aim of science is to generate theories that are empirically adequate. To say that a theory is empirically adequate is to say that all of its claims about observable phenomena are true. So the standard way of thinking about science is that science gives us truths about both observable and unobservable things. Physicists, for instance, will talk about photons and quarks and so on. Now, nobody has ever seen a photon or a quark. But because our theories that postulate photons and quarks are so powerful, we tend to assume that photons and quarks really do exist. The constructive empiricist resists this view. He says, no, science gives us knowledge of the observable world, but we should be agnostic about what it says about unobservables. For all we know, perhaps there are no photons or quarks. Now, a question immediately arises here, which is, well, what exactly counts as observable? According to Bas van Fraassen, something is observable only if it can be perceived with the unaided senses. If you have to use an instrument to detect something, then that thing isn't observable. So when I place samples of stagnant water under a microscope, I seem to see various tiny creatures swimming around in it, including paramecia, which is a unicellular protozoan widely studied by biologists. This is an image of a paramecium. Paramecia are too small to be seen with the naked eye, so Van Fraassen's view is that paramecia are not observable, and therefore he would be sceptical of their existence. For all we know, there are no paramecia. Now, for anybody who's ever used a microscope, this conclusion probably seems fairly outrageous, especially if you've worked with microbes like paramecia for a long time. They probably seem just as real as tables and chairs. And there are lots of arguments we can appeal to one way or the other concerning the reality of unobservable things. Again, check out my series on scientific realism. I have a long series where I look at some of the main arguments that have been proposed. But anyway, the question is, if microscopes don't show us images of real things, what exactly is going on when we look through a microscope? Now, Van Fraassen answers this in his article Constructive Empiricism Now by drawing an analogy to rainbows. Rainbows, Van Fraassen says, are public hallucinations. So what does it mean to call something a public hallucination? Well, there have been reports of mass hallucinations, where a number of people all apparently perceive the same object, but the object isn't actually there. The hallucination is generated by the sort of misfiring of individual perceptual systems, but it just so happens that everybody shares a similar hallucination. Now, whether an apparent object is a hallucination in this sense can be determined by performing certain simple tests. For visual imagery, you might take a photograph. Since a mass hallucination is a non-veridical experience, the camera obviously wouldn't detect the hallucinated object, so it wouldn't be captured in a photograph. But by this criterion, rainbows are obviously not hallucinations because we can take photos of them. So the problem with rainbows, says Van Fraassen, is that they lack certain crucial invariances. His claim is that if something is a real entity, then observations of it, including photographs, will show it as existing in the same place in space at any one time. Real objects have a specific spatiotemporal position. Rainbows do not. If two people at different vantage points look at a rainbow, they will locate it in a different place. As Van Fraassen says, and I quote, "I see a rainbow, and you say you see it too. See what too? You are not seeing the rainbow I see, for yours is located in a different place." So at first it seems natural to treat rainbows as real things, but it's just impossible to maintain that interpretation. If you try to walk up to the rainbow, you'll never actually get to it. It will seem to move away and then it will disappear. Somebody at a different place will report seeing a rainbow as well, but they won't see it in the same place that you see it. Rainbows are they're sort of vague and ephemeral. There is not, in fact, a real shining coloured arch extending into the sky. So we can't treat rainbows as real things. On the other hand, they're not caused by misfirings of the perceptual system as normal hallucinations are. And so Van Fraassen calls them public hallucinations. Nature sometimes creates conditions where there appear to be objects, and these apparent objects are detected even by instruments like cameras, but there are in fact no such objects. And Van Fraassen suggests that we can interpret the images displayed by microscopes in a similar way. Perhaps such images are veridical, perhaps they show real things, but for all we know, they might be public hallucinations like rainbows. Since we can't shrink down to microscopic size and check directly whether the paramecia images shown by microscopes correspond to real paramecia, we should remain agnostic about the existence of paramecia. For all we know, the paramecia images shown in microscopes are like rainbows. They are public hallucinations. Now, so I'm not really so concerned here with Van Fraassen's views on microscopes. As I said, I have a whole series where I talk about that. But I do want to talk a little bit about Van Fraassen's analysis of rainbows, which I think we might object to. So I suggest a somewhat different interpretation. On my interpretation, rainbows are real things. They're just as real as tables and chairs. They are quite straightforwardly part of the furniture of the world. Now, perhaps we shouldn't say that they are that they're standard objects, right? So we should say that they're not standard objects, but many entities in the world are not standard objects. The world contains shadows, holes, mental states, multinational corporations, the global economy, the internet, and so on. None of these entities are things like tables and chairs, but they still exist, they're still real. Van Fraassen objects to the reality of rainbows on the grounds that they don't have a specific spatio-temporal position. But then, what is the spatio-temporal position of the local golf club? So we can give a specific position for the building. We can give a specific position for the individual members and for the equipment and so on. But what about the club itself? Notice that the golf club itself is not identical either to the building or the individual members or the equipment, nor is it identical to the conjunction of all of these, because all of these things can change while the club itself persists. The building where a golf club is usually held could burn down, but that wouldn't destroy the club. The members of the club could die, but provided they're replaced, the club can continue. Now, of course, we can give a somewhat vague location for the golf club. We can say, well, it's in Truro, or it's in Cornwall, or wherever. But we can also give a vague location for rainbows. We can say that the rainbow is in the sky above the village. Indeed, sometimes the location of a golf club is actually even more undetermined than the location of a rainbow. Suppose that the members of a golf club all travel to a different part of the country as part of a golf tournament. Well, in this case, we'd probably say that the golf club has travelled to the tournament, right? We would be able to sort of precisely track the movement of the golf club from its standard location to its location in the tournament. On the other hand, suppose that each individual member of the golf club travels to a different part of the world for reasons that have nothing to do with golf. Well, then, where is the golf club located in that case? I mean, I don't even know how to begin answering that. It sort of seems like a silly question, actually. So, I mean, golf clubs don't seem to have spatio-temporal locations either, but they still exist. Now, I suppose one point that might be made here is that there is a difference between golf clubs and rainbows in that golf clubs are perhaps, they immediately seem like vague and indeterminate entities, whereas rainbows seem to have a specific shape, and they seem initially to have a specific place. The problem with rainbows, it's not so much that we can't pin down exactly where they are located. Indeed, very often you can state quite precisely where the rainbow is. The problem is that it moves to a different place whenever you move. It's at a different place to each individual person who sees it. So I think, yes, it's true that golf clubs and rainbows differ in this respect, but the point is whether we should use this specific spatio-temporal location as a necessary criterion of reality. And I think the example of golf clubs does suggest that we shouldn't. Specific spatio-temporal position is just one among many of the properties that standard objects have. Other entities diverge from standard objects in various ways. Some entities have specific spatio-temporal positions, other entities do not. Similarly, some entities have a definite shape with well-defined boundaries. Again, tables, chairs, cars, trees. Other entities are more amorphous, like clouds and emission nebula. Why not take the property of having a definite shape with well-defined boundaries as a criterion of reality? In which case, clouds and emission nebula would be public hallucinations. Similarly, some entities are opaque. Standard objects are often opaque, whereas some entities are transparent or translucent. Maybe glass is a public hallucination. So I think that this kind of points to a problem with the very idea of public hallucinations. Recall that Bas van Fraassen is an empiricist. The attitude of the empiricist, I guess to sum it up very simply, might be believe it when you see it. Right? The empiricist holds that knowledge is limited by our sense experience. The empiricist insists that all claims about the world be empirically testable. How do they affect what observations we make? And that, of course, leads to the anti-realism about scientific theories. We can know about the observable, but no matter how powerful our theories are, they can never give us knowledge beyond the observable, because by definition we can never directly check whether our theories accurately capture unobservable processes and events. Now, prima facie, rainbows are denizens of the observable world. Everybody with working vision can see them. They're captured in photographs. They reliably occur when certain specific conditions obtain. So once we eliminate rainbows by treating them as public hallucinations, well, for all we know, maybe mountains and trees and so on are also public hallucinations. They're just public hallucinations that are very good at imitating real objects. Basically, if Van Fraassen wants to say that the property of having a specific spatio-temporal position is a criterion of reality, well, some explanation needs to be given for why public hallucinations can't have a specific spatio-temporal position. But what could this possibly be? I just can't see any reason why a public hallucination shouldn't have a specific spatio-temporal position. So, for all we know, maybe everything is a public hallucination. Of course, the question of whether everything is a public hallucination, or whether some things really exist as real material objects, is one that a good empiricist will probably decline to answer. You might notice that this bears some resemblance to the debate between idealists and materialists. So the idealist, such as Berkeley, says that everything is ultimately mental, everything is part of the mind, there are no material objects. The materialist says actually a great deal of objects are mind independent. Now, for many empiricists, they would say that this debate really makes no difference. There's no way of testing either hypothesis. For all practical purposes, we simply say that there are various objects, there are trees and mountains and tables and chairs and so on, and the fundamental metaphysical nature of these objects, so whether they are fundamentally mental or material, well, that's just not something we have any access to, so we should be silent on that question. The same goes for the question of whether objects are public hallucinations or are real in some deeper sense. There are trees and mountains and tables and chairs. Similarly, there are rainbows. Perhaps trees are public hallucinations. It really makes no difference, at least not from an empiricist perspective. Trees are still real in any sense of the term that matters. So I think that this notion of public hallucination is not really a very useful one for an empiricist. There isn't any substantial distinction between a public hallucination and a really real object. But let's assume that we should take specific spatio-temporal position as a criterion of reality, and let's assume that the notion of public hallucination is coherent for an empiricist. Well, this doesn't necessarily tell us much about rainbows, because rainbows actually do have a specific spatio-temporal position. Let's say you look at a cup. Somebody at a different vantage point will see a different part of the cup. So with standard objects, when you move around them, different parts of them are revealed. So I'd suggest that the same is true for rainbows. What we can say is that the actual the bow in the sky that you see is just one part of the whole rainbow, which is a much larger entity. As you move around, different parts of the rainbow are revealed. Of course, on this view, a rainbow as a whole is not actually an arch shape. The arch shape is just the part that you see. The rainbow as a whole exists across a rather large amorphous part of the atmosphere. When the right conditions are obtained, so when you have sunlight and you have droplets of water in the atmosphere and so on, rainbows occur. You only ever observe part of a rainbow. And to do that, you have to look at an angle of sort of 42 degrees from opposite the direction of the sunlight. This will reveal the characteristic coloured arch. As you move around, the arch appears to move. But what's actually happening is that different parts of a larger entity are being revealed. So, contrary to what Van Fraassen says, when two observers look at a rainbow, they actually do see the same rainbow. They just see different parts of the same rainbow. Now, certainly rainbows don't reveal their parts in the same way that standard objects do, but this is because rainbows are not like standard objects. They're not like chairs and tables and cups. Different kinds of entities require different conditions for observation. They reveal themselves in different ways. Similar points apply to other phenomena that Van Fraassen labels as public hallucinations, such as mirror images and reflections on water. Again, for Van Fraassen, the problem with mirror images is that the mirror shows different images at different vantage points. While I would say that mirror images are real things, different vantage points reveal different parts of the mirror image. Furthermore, if you move the mirror, the mirror image changes. Mirror images are just as real as painted images. It's just that they behave in rather strange ways. So that then is another way of thinking about rainbows that doesn't require us to view them as public hallucinations. So a couple of objections. Well, maybe objected that, okay, so if a rainbow appears to be in place X, and then you go to place X, the rainbow disappears. Go back to where you were before, you see the rainbow again. So if rainbows are real, it seems like they come into existence and then go out of existence depending on where I am, and that makes no sense. However, I think this is a rather simple error, which again, once you realise that a rainbow is a much larger object than what you see, you avoid this error. The rainbow does not disappear. When you go to the place where the rainbow seems to be, you are now standing in that part of the rainbow that you saw before. It's just that you can't see that part anymore. Again, this is due to the peculiar way in which rainbows reveal themselves. At vantage point X, you see a part of a rainbow that appears to be at vantage point Y. So you move to point Y, now you don't see any part of the rainbow. But the rainbow is still there, assuming the atmospheric conditions haven't changed. And somebody else at point Y would still see it, and they would see that you are standing in it. You are standing in the part of the rainbow that you saw from point X. So again, the rainbow as a whole object occupies a very large area. You only see a very small part of it. And the part of it that you see changes depending on where you move. A second objection concerns the colours of rainbows. Let's say you see a part of a rainbow at point X again. You then move to point Y. The part of the rainbow that you see from point Y may overlap somewhat with the part that was seen from point X. So, sort of like in this diagram, as you move to the right, the rainbow will sort of seem to move left, or will it move right? Well, it doesn't matter which way. Anyway, the point is that as you move, the rainbow will seem to move. So you move to a different point, and the rainbow seems to shift to the left. And the problem here concerns the colours, because the place before that was wholly red may now appear wholly green. And this seems bizarre. This seems to entail that an entity can have two colours in the same place at the same time. And that doesn't seem to make much sense. How can redness exist everywhere, and then you move somewhere else and it's wholly green? Well, I think the primary response to this is that this is certainly odd, but precisely the same occurs with the colour properties of standard objects. If you have, say, a table and a lamp, then as you move around the table, the lamp will illuminate and hence alter the colour of different parts of the table. This is perhaps strange, but it's a feature of colour properties in general, not rainbows in particular. In fact, I don't think it's so outrageous to say that an entity can have two colours at the same time, especially if we're dealing with things like rainbows. Rainbows aren't normal entities, they're not like tables and chairs, so why would you expect them to work like tables and chairs? A third objection. So if we're going to treat rainbows as real entities, why shouldn't we go all the way, as it were, and say that actually after images, the objects that we seem to see during after images and the objects shown in dreams are real entities? I mean, the supposed problem with things like after images and dreams is that nobody else perceives them. But why not say, well, after images are real entities that are unusual in that they present themselves only to one person? So, I mean, the point I made earlier was that we can say that entities that have no spatio-temporal location are real. We can accept an ontology including those. We can say that entities that can only be detected when one is standing far away from them, as with rainbows, are similarly real. So perhaps it seems a small step to say, well, entities that are revealed only to one person are also real. The world contains many different kinds of entities. Some of them are rather odd. Well, I think the answer to this is that knowledge sort of starts with the human community, right? Knowledge is generated by humans. It's a cooperative community activity. We rely on other people to lend support to or to criticise our own claims, and by this method we gradually build up a picture of the shared world. Now, from this point of view, the very fact that after images and dreams appear to only one person is itself a fundamental difference between these things and rainbows. So, let's say you stare at a red light, you look away and you seem to see a floating bright green object. Is there really a floating bright green object there? Well, obviously there's simply the only reason to believe that there is by your own testimony that you see it. So, I mean, let's sort of lay out the options a bit more precisely. One person might say, well, there is no green object, right? Metaphysically, that green object doesn't exist. Or we might say, metaphysically, there really is a green object, it's just a very strange object. It's a strange entity that reveals itself only to one person. Now, I think that any good empiricist would decline to answer this kind of metaphysical question. Whichever option we choose here really makes no difference. The point is that the green object is not part of a shared world, and that's why you say it's not real. And that is a fundamental difference between the green object and rainbows. Some of the things that we seem to perceive can be perceived by anybody with the right perceptual system, and hence can be verified. Some of the things we seem to perceive are wholly private. And it does, I think, make sense to draw a distinction here. And so when we say that an entity is real, I think that what that means for somebody with empiricist inclinations, as Van Fraassen has, is that it's part of the shared world where we can verify things and we can check with other people. And that's certainly the case with rainbows, but it ain't the case with the floating green object. So anyway, I mean, the point here is just that I think that it is perfectly reasonable to say there are rainbows, and we know that there are rainbows. We should be realists about rainbows. If paramecia are like rainbows, then we should similarly be realist about paramecia. Anyway, that's pretty much it. One point I do want to end with, though, is, I mean, following Van Fraassen, I've sort of tried to take a bit of an empiricist perspective in this video. Most people, I think, are scientific realists. So what should a scientific realist say about rainbows? Well, even if we accept the current best explanation of rainbows, I think we can still treat them as real entities. So according to the current scientific explanation, rainbows are caused when sunlight enters water droplets and is refracted, so that it slows down, basically, and then it's reflected off the back of the water droplet, and finally it's refracted again when it leaves the droplet. So when it's refracted, it slows down and hence becomes bent, and then it's reflected, and then it's refracted again. It speeds up and bends again, and that's part of the explanation. The complete explanation tells us how the colours are formed, why the rainbow is always seen at 42 degrees from opposite the direction of sunlight, and so on. The important point is that our best scientific explanation says that rainbows occur due to the interaction of light with droplets in the atmosphere. Now, I think that this doesn't entail that rainbows are not real. Again, they're not standard objects like tables and chairs, but they are, perhaps we might say, higher level entities that emerge when the right conditions obtain. I think that everything I said earlier still applies, right? Rainbows are very large, amorphous blobs. You only ever see part of a rainbow. As you move around, different parts of the rainbow are revealed, and so on. So anyway, that was a little bit about rainbows, and that's it. Thanks for watching. Goodbye.